All right, let's take a quick look at the properties of logarithms. Now, this is going to be big for the whole rest of the section because we need to be able to manipulate these logarithms to put it in a simpler form that it's a little easier to deal with. Now, before we talk about properties of logarithms, we need to talk about properties of exponentials. If you have something with the same base and you multiply them, we discover that you can add those exponents. It's equivalent to that base and just adding your exponents. Same thing if we're dividing two exponentials with the same base. It's the same as that base and subtracting your exponents. We also discovered if you have an exponential and you take an exponent of it, it's just like multiplying your exponent. Well, if you remember, okay, when we solved something like this, or when we turned this into a logarithm, log base b, this is m, this is x. So what is this logarithm? This logarithm is an exponent. So these logarithms are going to do the same thing that the exponents did. So here, if my result is being multiplied, then that's the same as me adding my exponents. If I'm dividing my result, then that's the same as me subtracting my exponents. If I'm taking a power to my result, that's the same as me multiplying my exponent by something. So these rules right here mirror these rules right here, okay? That's how these properties work. Now there's one other property I need to show you, and that is the change of base formula. Now this guy used to be really, really important because it was really hard to do logs. We didn't have sophisticated calculators, and even when we started to get calculators, it was still really hard to solve these guys. Now, nowadays, so the reason that was so important is we made these nasty long log tables for the two most common types of logarithms, which was natural logarithms and common logs, base 10. So you had to really convert any logarithm to either a base 10 logarithm or a natural logarithm. That's not really true anymore. We have calculators that can handle that, but there are times where it's still important to be able to change your base, especially to change to the natural log, which, again, natural logs are really, really nice in calculus. So being able to change to a natural log is really important. So let's get to the formula. So let's say I've got a logarithm and it's base a. Doesn't really matter. I can rewrite this as a ratio of two logarithms. Now, I'm not going to give you the y on this right now. I can show you a proof if you want to see it, but what's important here is if, for instance, I had log base 7 of 3, and I want to change that to, say, a natural log. And I just go, okay, I'll do a natural log on top and bottom. So I've changed my base, and I put the base down here and the inside part up here. Okay, so that's how you change the base of your logarithm. We're going to talk a little bit more about how we would use these properties, but I'm going to do that in a different video.